Hello chemistry students, this is Mr. Ferguson. I am flying solo today. Mr. Hunter was unavailable, but I'm going to walk you through lesson 5.6, which is acid nomenclature and hydrate nomenclature. So the objectives for the lesson are for you to recognize the formulas of some common acids and be able to name acids from their formulas using the IUPAC rules, and then to explain what occurs in a hydrated crystal and to name and write formulas for compounds which exist as hydrated crystals. So we're going to get started with that right now. So to begin, we're going to discuss acids, and we're going to get into this in depth later in the course, but acids are a class of ionic substance, and they produce hydrogen cations when they're in aqueous solution. At least that's one definition. Now, as you're going to come to learn, there are several different ways we can define acids. But the generic formula would be HA, where the H is the hydrogen and then the A is the anion that the hydrogen is associated with. And when the HA, or the acid, dissolves in water, it's going to dissociate and produce these hydrogen ions as well as the anions. So we're going to have you copy down this chart with the naming rules. So the naming rules for what to call the acid are going to be, the name's going to derive from the suffix that is the ending on the anion. Okay, so for example, okay, if the ending is "ide," as in chloride, then the acid is going to be hydro something ic acid. The something is going to be the stem from the anion's name. Okay, so let's go through the three and then I'll illustrate it a little more with some examples. So if the anion ends in "ite," nitrite, phosphite, then the acid's name is going to be the stem of the anion's name with the OUS suffix and the word acid. If it is an 8 ion, oxalate or sulfate, okay, then it's going to be stem ic acid. So if you copy that down, then let's try to apply that in a situation down below. So if we have the compound hydrogen chloride, I'll change colors here, you should know enough about ionic compounds to be able to rewrite that guy as HCl, which when it is dissolved in water, when it is aqueous, makes, of course, probably the best known acid of all. Since we have an "ide" ending, we're going to go up here, we're going to call it hydro stem chlor ic acid, hydrochloric acid. So hydrogen sulfate, which, remember, sulfate's SO4 2-, so the formula is going to work out to H2SO4. That's an 8, so it's going to be stem ic. So it's sulfate. So this one becomes sulf, and we actually go back to we stick the UR in there, sulfuric acid. Again, when it's dissolved in water, it's going to be sulfuric acid. We have hydrogen nitrite, that's H. Nitrite is NO2 with a -1 charge. HNO2, that is going to be an ite suffix, so it's going to be stem nitrous, suffix is us, acid. So a lot of these acids you'll just come to recognize their formula just because you see it so often. Hydrochloric acid, is the prime example. We see that constantly. Sulfuric acid you'll probably come to know, but if you come to one that's unfamiliar, again, if you can name the anion that's in it, and then you just apply these rules for the suffix to name it. Alright, so we've covered acids, now let's discuss hydrates. Hydrates are chemical compounds that can be ionic or covalent, that they include water molecules as part of their crystal lattice structure. So these are substances that will actually absorb water, and they kind of weakly hold on to the water molecule. Now it's not actually part of the compound. It's not chemically bonded with a strong ionic or covalent bond to the other atoms that are in there, and thus it can be driven off by heating. However, you need to account for that water. Like if you're going to mass out some of the compound, you need to understand that it's going to have some weight in it due to water as well. So we need to recognize, when compounds are hydrates. Okay, and we have a way that we write that. So when we name them, we're simply going to say the name of the compound. Then we're going to give a prefix which indicates how many water molecules are joined up per formula unit or per molecule of compound, plus the word hydrate. Okay, the formula that we're going to write, if we want to write it as a formula, we're going to simply write the ionic formula. We're going to put a dot. I used an asterisk, but it would just be a dot. And then X would be the number of water. So X could be a number from 1/2 up to 10 or more waters, depending on what it is. So I know this is probably a little overwhelming at this point. Let me, first of all, I'm having a hard time finding out where to stick this chart. But you probably should copy down this prefix chart, and these are the same prefixes we're going to use in covalent compounds, so it wouldn't hurt you to learn them now. So if we have 1/2 of something, which is a little unconventional, but sometimes it's used, it's the prefix hemi. 1 is mono, 2 di, 3 tri, etc. All the way up to deca for 10. And they actually go beyond that, but 10 is a good starting point for us. So, for example, let me move this up out of the way. There's a compound which is called copper 2 sulfate that absorbs water into its crystal structure, and for every formula unit of copper 2 sulfate, it absorbs 6 waters. So we're going to say its name as copper 2 sulfate hexahydrate. So we're just adding the hexahydrate at the end. So the hexa tells us 6, the hydrate tells us there's 6 water molecules associated with a formula unit of copper 2 sulfate. In written form, it would look like this: CuSO4, that's copper 2 sulfate, dot 6H2O. Alright, so let's do a little bit of practice here then. I've got a name, we're going to write the formula, and I've got a formula, we're going to write the name. Actually, let me correct myself. Before we practice, I want to show you, I just took a picture of a bottle of sodium phosphate that we use in our lab today, and I wanted to show you that this one is in fact a hydrate, sodium phosphate, Na3PO4, dot 12H2O. So if we were going to name this compound, now they just name it sodium phosphate, but this would be sodium phosphate dodeca, that means 12, dodecahydrate would be what it is. And so when you weigh this out, you have to account for these 12 waters in the weight if you're going to weigh some out to get the amount that you actually want. And that's going to be an important point as we go forward. Alright, so I'll get this shrunken up and out of the way here. Let's go back to the practice problems now. So we have a compound, beryllium sulfate tetrahydrate. Okay, so again, using our naming rules, we know that beryllium is a group 2 metal, so we should be able to figure out it's got a +2 charge. Sulfate's one of those annoying polyatomics that we just have to know it is SO4 and it carries a -2 charge. So using our crisscross rule, we should be able to just write the correct ionic formula as BeSO4. The 2's are going to reduce out, and then we need to tetrahydrate, so we're going to put a dot. We need to know that tetra is the prefix we use for 4, so that means 4 water molecules are associated with each unit of beryllium sulfate. Alright, now down at the bottom then we have one where we're only given the formula, and we would of course be asked to name this one. So again, we're going to look at the ionic formula at the front. Hopefully you can figure out that that's barium chloride, and barium chloride is associated with 2 H2O's, so 2 would be di. So since it's a hydrate, we're going to call this one barium chloride dihydrate. Alright, so let's go on and check out the post-video questions and see if you can apply some of these concepts for naming acids and hydrates. Okay, so here are the post-video questions, chemistry students. Number 1, name that acid. The first one is HCl, but since we already kind of did this one and you have it in your notes, I also added another one, which is H3PO4. So remember, first you want to name the anion part of the compound. So you know what's Cl called when you name it, what's PO4 called, and then see what the suffix is on that anion part, and that's going to tell you what to call the acid. So see if you can figure out especially this one. Alright, second question, what is a hydrate? What do we mean when we say a chemical is a hydrated crystal? See what you can do with those, and we'll talk about it next time. See ya.